Now continuing with our program, we will have a talk from HArper, Composites.
Desculpa, gente, estava vazando o som ali.
It will be about advances in manufacturing composites for the automotive industry. And our speaker is Mr. Francisco Antunes, also known as Chico Antunes in the market. Everyone knows him. And we're turning on his screen. Não está dando para ouvir. I'm sorry. We're not getting audio.
Alô, tá ouvindo? Consegue ouvir? Oi, melhorou? Beleza. Obrigado.
While they fix the issue, I would like to show a little bit about what we did in changing the manufacturing of bus parts, the front, the rear, and some parts of the inside. We migrated the type of process aiming at improving the manufacturing structure, reducing cost, and the efficiency of the production process. We're going to talk about the challenge of making these changes. We have a very traditional industry, and in Brazil, it has very little technology. We still see a large number of companies working with spray up and some older systems. We are doing some things in RTM, manual lamination. I'm going to have to switch the talks. This is not it.
Parece que hoje é o dia do contratempo.
Now it seems that it's working. Can you all hear me? Now we can start. Let's see if it's going to work. Feels like I have another problem. So when you talk about change, we always have to overcome some barriers, and somehow we need to create a system for that to happen because it's not simple to get people out of their comfort zone. So every time we talk about change, and we talk about change in a manufacturing process that already works, we're going to find resistance, denial. Oh, I've been doing this for 50 years and it's always worked. So there's an infinite number of reasons for them not to accept the change. So when we started this challenge at Fiberbus, that's part of the CAIO group, and we started to implement the new system, we went through all of that. So basically what happened is the sense of urgency, because when we talk about collective transportation, everything that weighs something is bad. Everything you could decrease in that sense and improve is necessary. So currently there are some countries when we export a bus, it has a weight limit, and otherwise they'll send it back. Like Uruguay or Chile, all of them already have restrictions regarding the number of passengers transported and maximum weight. So that's where the sense of urgency plays in and expedites things. So, in addition, change in the team, and that's normal because some people just don't want to cooperate and they won't. And created the vision, communication of the vision and what that was, and empowering the employees. That's another huge barrier of overcoming in manufacturing overall. Coming to a point where the operator can come up and say, I'm not going to make that part anymore because I'm making parts with defects. We usually have a control system that tells him that he's making a part with a defect, and then he gets upset with the controls. So based on that philosophy of change, we want the employee to come up and say, I made it once, there was a problem. I make it twice, there's a problem, help. And they raise their hand so they don't continue making a part with problems. We call that quality assurance and not the quality control concept that someone at the end of the line is going to show the defects. We have to find that before we get to that point. And then win over everybody who's involved so that they understand that it's the process, that the process is going to be better in many different aspects. Consolidating change and accept that we've created a new culture. We know that those are in the industry for a while now, creating a culture in the industry and moving all the barriers. You need a lot of attention, TLC, sweat, and a lot of patience. So what's customer needs? What do they want? They want a lightweight bus. They don't want a heavy bus that's going to waste more fuel and unnecessary material. So what do I have to do? What am I going to do? What's the product application for that? And look at all product characteristics. That's very important. And it's very important for us to know all of that. And what process I'm going to work on. Here are some processes in manufacturing composites. We have the VPI that's commonly known as silicone, and we have manual laminate. There's a process that's called finish gel. It's a part that doesn't require painting afterwards. It's already ready. Protrusion and a lot of 3D printing, which is quickly evolving. Spray up. For those who work with fiber, have already glued their foot down when they were visiting a company that does spray up. Because for those who don't know it, it's an equipment that's spraying, chopping up the fiber and spraying the resin on top. And then comes the rolling process, manual. So it's highly pollutant, has a lot of residue, a lot of loss, and very hard to control the thickness and weight of the part because you depend on an operator. So when they come in on a Monday after they drank a lot on the weekend and their hands are shaking, you're probably going to have an issue with thickness on the parts. Too thick or not thick enough. The other traditional method that most of you know is hand layout. So, and they manufacture the parts. RTM Light and VPI are very similar. The difference between the two systems is that in RTM Light, you have a rigid counter mold, and in the RTM system, you will have smooth finish and perfect finish on both surfaces. Not only on the surface that's in contact with the mold, but also the counter mold of fiber. Because the RTM counter mold is rigid and in fiber, and you can get a finish, a very good finish on both sides. So my counter mold is silicone, so I can calibrate the thickness of my part even better. And compared to RTM Light, and the disadvantage is that it's not going to solve all problems. It doesn't have a perfect surface with a smooth finish on both sides. There's on the side of the mold and on the other side, no, as a general rule. Is it possible? Yes. But if we're honest here, and I'm a guy that works with VPI, it can say you can do it, but it's not worth it. It's best to do RTM Light. Finished gel is a process that fits in all these others. The only difference is that I use a gel that will give me class AA finish, and I won't have to work with painting afterwards. The basic difference in that process is exactly that. So if you use this process of finished gel, it's spray up, or hand lay up, or RTM, or even VPI, you have to be careful with the type of mold that you have for your part. Because it's no use doing amazing work with finished gel if the mold doesn't let me demold, and when you pull at it, you're cracking it. And then you're going to have a problem with the gel, you're going to have a crack, so it's no longer a perfect part. And for those that work with it, in finished gel with small repairs, it's practically impossible to do that. You'll see a difference in the color. And within the challenges and that change, manufacturing the fixtures that'll give you the structure for the part that you want. Setting up the assemblies, that's another challenge because we have a number of parts that we have to bring together. And the automotive painting process, which is the primer and the final paint. So it's just a common process in automotive painting. And the other one is the manufacturing system with 3D printing. So there's a small printer. Our small one will be available in October. It's 4 by 2.5 and parts for up to 2 meters high. So we want to print the molds and deliver them finished.
And the other side is protrusion. Most people know that. So these parts have fiber and resin that's stretched, and you can have many profiles that can be manufactured. The results we've obtained when changing to the VPI process. When I did RTM Lite and switched to a VPI, because of the finished service, I was able to lower the weight by 47% of the part. I increased the proportion of fibers. Everybody knows that the more fibers you have in the system, you'll have higher mechanical resistance. The more flexible part is more resistant. And my residue percentage decreased reasonably. And there's a process that we're growing, which is working with zero issues, where you have to take away the laminated parts and throw them out. When you work in VPI, you can have the fiber in exactly the same size as the part. You have the mold, and when you demold, you'll have imperfections of cutting the fiber and some burrs. In that case, we use a file to take away the imperfections. Mechanical essays, tensile strength, RTM light, and flexion resistance, and significant gains just by switching from a stiff to a flexible mold in silicone. Because we gained the mass that I mentioned, so I decreased the amount of resin in my part. And when we do that, decrease the volume of resin, you're taking more advantage of the capacity of the reinforcement. The reinforcement is the fiber, so the more fiber you have in your system, the better. Internationally, the ideal, and we work in aeronautics with that, 70-30, 70% fiber and 30% resin. That's where we get best results in the mechanical conditions. So there's the elasticity module that improves a lot, and traction and tensile strength also does, just by changing from an RTM conventional system, RTM Lite, to a VPI. So basically what happened was that I switched the counter mold. I didn't touch the mold. RTM mold can be used as well. I took out the counter mold that was fiber and switched to silicone. This is the mold that we're talking about that we changed. That's the back of a truck. Excuse me, a bus. That's the back of a bus. So you see a person can fit in there. And this is a conventional RTM, and we took out the rigid part of RTM and built the counter mold in silicone for the VPI. So what does this change in the system? In the rigid mold, you don't change anything. It's still the same. What we change is how we inject resin and how we manage the vacuum in the mold. The basic principle and why we reduce the volume of resin. When I have a conventional RTM mold, I have to calibrate a certain thickness. So let's say I want 5 millimeters. And I'll put my fiber in there, and whatever's missing in that thickness will be full of resin. In conventional RTM, I inject the resin on the side of the mold and have the vacuum through the center. So automatically, the entire channel around the mold is full of resin, and I'm going to throw that out because it's in that channel. In this case, when we have EPI, it's the opposite. The vacuum is through the rim and inject in the points inside the mold. So I put in the number of resin necessary, depending on the amount of fiber that I want in the mold, and vacuum. And since the vacuum removed all of the air in the system, people are like, oh, vacuum's pulling out the resin. No, it doesn't. It takes out all the air in the system, and when I put in the resin, it's going to take up that space where air would be. So it reduces a lot the amount of bubbles and micro bubbles. And that's also one of the reasons why we have mechanical resistance. In addition to decreasing the amount of resin you put in, you're decreasing a lot of air and gas in that process. That's it. That's what I wanted to show you. And I'd like to take this opportunity to invite you to visit our booth at the Allen booth. We have a system that you can touch, and you can see the counter mold of silicone and see something new that we have about our printer. I have a printed mold with a lot of advantages. So I can take your 3D design and put it in my machine, and you give me the 3D print, I'll put it in my machine, and then I can deliver it ready. I don't have to go through a model part. I don't have to go through that process. And then the question that everybody asks, what about the cost? Same cost as making a model and a mold. It's very close. There's no price difference. That's it. In case you have any questions. Any questions from the audience?
Chico. Tem pergunta?
Do you have a question?
El gel de acabamento, hay que fazer trabalho adicional.
Do you have to do any additional work for the finish and gel finish with the 3D mold? Do you have to do any extra work and an extra finish? Do you have to polish? Yes. When we make it in 3D, it's going to be many imperfections. After that, there's a mechanized one, milling, and after that, you apply the gel coat. We've already developed a system to apply gel coat. So you can use a paint gun with 1.5 millimeters and not 4, because gel coat, you usually use 4 millimeters. So we were able to decrease that. It's a different technology that's anchoring the system.
But it is necessary, yes.
Mais alguma pergunta?
Any other question?
Muito obrigado.
Thank you very much. I thank you. Thank you for the opportunity.